All right, so today we're in for a treat. We have Wang. He is the founder of AutoGen, now called AG2, which you can find at ag2.ai. So if you go to the website, the taglines are the open source agent OS, as well as build production ready multi-agent systems in minutes, not months. So Chi, welcome to the podcast.
Hi, Ben. Thank you for inviting me.
All
Glad to be
right.
here.
All right. So you're an experienced researcher and engineer, right? So there's many things to work on, but you settled on multi-agents, tools for building multi-agent applications, right? So um,
Yeah.
can you explain why you settled on this problem, and also what are the specific problems you folks are addressing with AG2?
I see. Yeah. Thank you for that question. Maybe I can ask the second question first. The problem we're focusing on is to create this open source agent OS as a common infrastructure for developers to build agents and agentic software. So that's I think the kind of shortest answer to the question. It includes how to quickly leverage uh, the latest generative AI technology and create really powerful agents and also multiple agents working together to solve complex tasks and then quickly deploy them. So that's a mission I'm on. And regarding how I kind of decided to work on this problem, that's actually took multiple kind of turn points and related to my previous research experience. The starting point is I started the AutoML project about 6 years ago together with Qingyun. At that time, Qingyun was my intern, and later she joined Penn State University as a professor, and we kept working together over the years in developing that open source AutoML project. That project is for tuning the hyperparameters for machine learning models and choosing the best model for a particular application. A lot of research has been done in that. And about 2 years ago, 3 years ago, when GPTs and the ChatGPT, the very powerful generative AI techniques were invented, I started thinking about whether AutoML can be also useful for these new kind of models and what are the the most effective ways to use this model for building useful applications. That has been the spirit of AutoML and so on. So the first thing I tried is to apply a Flamel to tune the parameters for these GPT models, and found there's a big room for improvements in how to choose the best way to use this model. There can be a dramatic difference. For example, on some coding benchmark, we found the difference can be 60% versus 90%. By using the same model, but just choosing different configurations and maybe multiple inferences and other components outside of the model inference themselves. So I realized there's a very big, very large design space about how to combine these models and with tools and also maybe potentially human inputs to make them really useful to solve applications. But the developer at that time, developers didn't have a very good framework to reason about these large design space, and not easy to find the optimal design point. So I spent multiple months to think about what should be the right reasoning framework for that. Eventually, I chose use agents as a concept, as a most important and intuitive concept for people to be able to reason about that. So we started by building some two-agent conversation with one agent using language model to propose solutions, and another agent to simulate what user will do in response. Like, for example, execute some code or provide input back. So that worked very well. But then when users start using them, we quickly realize that's not enough, and we need to support beyond two agents, and then we started kind of building this full-fledged multi-agent framework. So then it just iterate over users, and we keep developing framework, and still and there's a big design space to work on. So that's kind of the starting point of it.
So obviously, Chi, we're still in the early days of agents and multi-agents, right? So people are trying to uh, across different organizations, different companies, trying to figure out what is this agent stack. So now you folks are using the term agent OS. So what are, in your mind, what are the key elements or key capabilities that will define an agent OS? Is it orchestration? Is it, what is it? So what is
Yeah.
exactly an agent OS in your mind?
Yeah, that's a very good question. I think the full picture is still getting more and more reached. We're still, like Jing and I are kind of carefully kind of trying to figure out all the pieces missing. And I don't have the full answer yet, but we prepare to have a like more complete picture. But I can tell you some of the components I think we're thinking about it right now. So first of all, there are, if you think about the developers' needs, developer requirements, it's roughly two parts. The first part is to prototype and experiment with the different ideas about how they think this agentic software should work. Usually that contains defining the agents and then defining how the agents interact. So these are the two most important fundamental building blocks. And then there's another big part is once they prototype, they need to kind of evaluate them. They need to deploy them in some test environment first, and then to deploy in production environment. So there are a lot of like deployment cycle, testing cycle after the intro prototyping. And AG2 is certainly kind of like started from the first part, like enable people to quickly experiment the idea, because we were like researchers and we know there are a lot of like fundamental kind of questions people were not clear about how they should reason about usage, and that need to be solved first. And then only when that part is reasonably kind of stable, we now we can enrich it with more kind of deployment support. So and for the so I'll mainly talk about the first part, the first bucket. Yeah.
So, Chi, so when people talk of agents, right? So these days,
Yeah.
they talk about the model that the agent will use, right? So what's the foundation model that the agent will use?
Yeah.
Will the agent have this notion of memory, or is there a framework? Is there a
Yeah.
storage layer for the
Yeah.
agent, right? So, and then
Yeah.
obviously you have monitoring and observability, and then agents. Yes, they use the foundation models, but everyone knows agents will need to rely on external tools, right?
Yeah.
So I guess what I'm trying to understand is where is the agent OS in all of this?
Yeah, exactly. So all the components you mentioned are some commonly used building blocks or emerging building blocks that people realize that are necessary. And the approach I want to take personally is to have a layered approach. We first figure out what is the minimal essential concept that's needed. What is like one layer on top of that, some derived components that should be included, and further we can maybe have more and more diverse components. So if you ask me like how I think about layer should be, I would say the two abstraction I mentioned earlier are the first order, the minimal set of concepts that is covers agents and agent interaction or orchestration. So these are the two kind of big buckets. They're also like connected. I'll mention that connection later. Now let's first think about each of them. In terms of like defining an agent, uh, the fundamental things we need to care about is what is the like capability of the agents. Do they use, for example, models as a backend? to support their behavior, or do they use other tools, non-language model tools, or do they use human inputs? So these are three kind of most, I think, most important different kinds of backends and capabilities that one agent abstraction should support. Here, if you think about the storage and other things, many of them can be categorized into the tool category, into the non-LLM tool category. For example, you can access memories with tools. You can build storage. You can save data, retrieve data, all via the tool usage. So I would say storage can be, and memory can be one like commonly used tool, a very important tool in the tool category. And once you have the mechanism to combine language models and tools, and also provide really strong kind of category of tools such as memories and others, you will have a modular approach to combine these components. And then in the agent interaction or orchestration category, fundamentally, we need to understand what are the most essential kind of interaction patterns among the agents, and we need to accommodate different requirements. And there are like different conversation patterns, for example, we should build in, and we should allow developers to customize them as well. And the last point I want to mention is there's a very interesting connection between the constructing a single agent and making a multi-agent interact, because if we start from the most primitive agents, like relatively simple agents, each of them just using a relatively simple backend, like just use model or use some tools or use human inputs. Even though these are simple, but once you put multiple agents interacting together, you could construct a stronger agent which contain these multiple agents inside, and that new agent becomes like a new kind of single entity that can be perceived as a strong agent with many new capabilities. They can use underneath special agents to perform different tasks. But once you do this, you can recursively construct stronger and stronger agents. So that just connect this multi-agent interaction with a single agent very nicely.
So the word orchestration, right? So in other parts of the stack, let's say in data engineering, right? So you have these orchestration tools like Airflow, Dagster, all these things. So that term carries certain expectations, right? So orchestrator should be able to schedule, right? So an orchestrator should have should be able to execute the task, right? Orchestrator may have a metadata store just to store metadata about certain tasks, right? And then an orchestrator should also provide you with some level of monitoring, because you want to know what's happening with your job, right? So is this notion of orchestration, is this similar to what you have in mind in the agent space?
Yeah, it is. The orchestration, the word orchestration is very interesting, because before the agents, even before we have the concept of agents, we have people who are building LLM applications without using agent abstraction, but maybe just orchestrate like when do we use a model to do inference, and then when do we invoke some tools after the inference, and then when do we invoke another inference, or when do we involve human inputs. That's also orchestration, just at a slightly different lower level, so that you need to read about these different type of entities. But when why do I think agent abstraction is very useful is because we can use the unified agent abstraction as a higher level concept. Once we abstract all these several different type of entities out, and just say, we can say one agent, for example, can represent one model inference as backend, another agent can represent a tool as backend, but they all share the same interface. They all send messages, receive messages, and generate replies. The difference is only like how they generate replies, right? Some of them use models, some others use tools. But once we kind of get rid of the like low-level details, we can simplify the orchestration as how we order these agents, like which agent should speak first, which agent should speak second. Do they all share? Do they all kind of speak in the same room and can see the message from each other, or do we have some isolation of some agents talk to each other and the other agent talk to each other, and then finally we combine the message and so on. So now orchestrations can be made in a more intuitive way, similar to how we think about a team of human like work. So a lot of design can be surrounded with that.
But like I said,
Yeah.
the term orchestrator also
Mhm.
kind of sets the expectation that you will give me some level of reporting so that I can understand what's happening.
Mhm.
You
Yeah,
know. Uh, so
that's right.
I don't know if you folks already have this capability. Like, if you have a bunch of agents, is there a dashboard where I can see what's happening?
That's a good question. The the library itself has some logging and telemetry feature,
There you
and
go.
that
There you go. Yeah.
yeah, and other I see in some other frameworks leveraging that to provide a more kind of user-friendly interface to easily understand what's going on, like when did each agent say anything, and what kind of capability did they use underneath. And there can be nested chat inside agents, so the structure can be hierarchical and complex. And I think
And you might
we still
even
need.
be able to tell me, hey, this agent is great, but it's slow and expensive. You know?
We did some recent research actually
Yeah.
about that.
Yeah.
The research is about taking a multi-unit system and take the execution logs of them and try to identify which agent should be responsible for the majority of the error, and when does the first error occur in execution. We haven't fully solved that problem. It's quite difficult, but we've compared several different approaches and find several like ideas that we can potentially combine to make better performance. But it's still a very open question actually.
So, Chief,
Yeah.
for listeners who have some familiarity with agents or starting to play around with building agents, right? So, they may
Yeah.
have heard of tools like LangGraph or Pru. So,
Yeah.
how does AG2 relate to these tools? Are they similar?
Yeah.
Are they addressing completely different things?
Yeah. I think broadly speaking, they all try to help developers to use the agent framework to develop their agents or multi-agent system. So in that category, they're similar. And I think the design principles are quite different. And the goal is also maybe slightly different as we start from different starting points. AG2 was the first one, the first uh, uh, real generic multi-agent framework that supports diverse applications. And then Korea and LangGraph, they also offer slightly different features. For example, LangGraph was mainly an extension of LangChain and tried to extend the chaining of models and tools to a graph structure. So for developers who are used to think about the problems and think about the low-level orchestration in the graph terminology, they may find it's a good fit. And for Crew AI, it's also like it also take LangChain as a dependency. So they start also to leverage the LangChain low-level components, but on top of it, it tries to have this notion of tasks and agents and some task agent assignment, and mostly focusing on like a sequential kind of execution of the agents. It's because of that sequential workflows is very easy to understand. So many people find it's also easy to get started with that concept. I think there are some slightly different like design points on them. But AG2 is really aimed for like some forward-looking multi-agent capabilities so that we can support all the different requirements, advanced requirements, not only just just sequential workflows, but mainly the conversations, multi-agent conversations of different kinds, including sequential chats, group chats, nested chats, and more recently we have a special kind of group chat called Swarm. It's inspired by the OpenAI Swarm framework. It's also very it's very intuitive to work at an even higher level program interface and with like, for example, conditional handoffs and context variable sharing that developers find very handy to build homogeneous systems. But all these different type of workflows supported by other frameworks, like including LangGraph, Korea, and Swarms, can be supported by AG2, and without any change of the fundamental concepts. So that just shows how generic and flexible this AG2 framework is. And plus, because it started early, it also has a lot of other advanced techniques, mostly driven by like research of the frontier capabilities. For example, we have teachability feature that allows agents to learn and improve over time. We have a captain agent that can manage other agents, create agents team, or use existing team agents on the fly, depending on the tasks, and decompose the task automatically and create different teams and adjust the plans if needed. So that's like agent creating agents, agents using agents kind of idea. We also have real-time agent that supports real-time communication combined with the Swarm agent that combines multi-agent capability and the natural interface. So these are just some examples, but there are a lot, very large number of like rich functionality and features in AG2.
By the way, the other examples I named, I think they themselves or people refer or other people refer to them as frameworks. You're the first one that uses the word OS.
Yeah, because we realized we initially also started as a framework. We used to say we're a programming framework, and as we work on this more and more, we realize there's a lot more to do, and we really want to build something similar to the previous like mobile OS or like operating system that supports the different fundamentally different kind of software, that's agentic software.
So actually, for our listeners, Chi and team have put together some good examples in their documentation, and you can see different kind of prototypical examples of what you can build with AG2. But Chi, I guess to give people a feel for how this works, and it's hard to do that without code, but maybe you can just uh, at a high level describe for our listeners what a typical workflow is for AG2. So what's the, how do you get started? So what would be the typical workflow to build an agent, a multi-agent app? Yeah.
Yeah, that's a very good question. I used to say we want developers to think about how to build the agentic system in two simple steps. The first step is to think about what agents you want to have to solve your problem. For example, how many agents do you need, and what are the roles of each agent? Just to describe them. And then second step is to describe how you want them to interact together using this conversation programming patterns we provide. We provide multiple kind of such patterns. So that's pretty much it. And a lot of other considerations can be added about how you define each agent and how you construct multi-agent interactions. But fundamentally, this is just how you think about it. So even people with no developer background, with no kind of coding background, they can think about problem as well, as long as they understand, for example, how we as humans solve problems. They can do that sort of reasoning, and the programming itself is relatively simple. And now, because we have some new features that even help them to further simplify this process, I would even say that you can start from just trying one particular agent in AG2 called captain agent. So that captain agent can take any tasks that you want them to solve and tries to automatically construct multi-agents and a team of agents and decompose the task and so on, and try to automatically solve that without you to specify what specific agents you want to have and what tools you want to use and so on. And of course, the cabinet agent is not guaranteed to solve every problem as you want it, but at least by observing what it's trying to do, because you can see all the different agents used or the new agents that are created, and all the successes and failures. But just by observing that, you may have now have some ideas like where you want to start. So now you can go back to this the first scenario I mentioned. Now you can start thinking about what agents you think are needed. Maybe you can use some of the agents suggested by the cabinet agent and add some agents that you find useful, that you know that should work well, and then also modify the agent interactions suggested by the cabinet. So this is kind of a new approach. I think that's even easier than previously.
So I'll put you on the spot here. So, what are your favorite 1 to 2 examples of actual examples of AG2 being used? An example or two of a
Sure.
case study. Ideally, they're not built by the core team; they're from the
No,
community.
they're
Yeah,
not.
yeah, from the
Exactly.
community.
I have on top of mind, I have 3 to 5 examples I really like. I would say them one by one. The first one is NVIDIA use case for chip design. So this is a use case with high value for like the hardware companies. Chip design is the most important task, but they are very time consuming. It can take days or weeks for human designers to perform each task, and with the help of AG2, they are able to successfully reduce that time to just minutes, and for multiple type of tasks. And for at least two of them, two types of tasks they are already using in production, and they're even researching more. So this is like the first one, because just of the value and how they cleverly leverage like human expertise to reach that perfect accuracy from some very low accuracy by just prompting the models to the perfect accuracy when using the agentic approach. So that's one I really like. And there's some similar ones because chip design is like one engineering principle, like one engineering domain that is highly kind of advanced, and but agent can help a lot. And there are a few others in science domains such as protein design, material design, and even more generally some psi agents developed by MIT group that can use ontology knowledge graph to navigate them and do reasoning, just similar to how human scientists do, and can evolve a lot of iterations, eventually generate very high quality scientific hypothesis and a full kind of report surrounding them. So that can have a potential to change the pace of science discovery, and maybe soon we will see AI designed drugs, for example.
So Chi,
Yeah.
in these class of examples, you have
Yeah.
a domain expert, maybe an engineer, maybe a scientist, and
Yeah.
normally they would have to do these tasks themselves manually, where they do a lot of work on the computer through a graphical user interface, maybe do web search, maybe use other tools on their computer. Is that correct? Is that a correct description? So then what the agent does is frees them up to do other things.
Yeah, exactly. So the like the human experts, even no matter whether it's a designer or human scientists, they spend a lot of time to collect data, think about hypotheses, collect data, and do experiments, and then refine the hypothesis and so on, or do debugging and deal with process a lot of data. Yeah, agents can help automate a lot of these if you know how to make them perform the same task as human, but with higher efficiency. So that's one common pattern I observed that very useful. And there are some similar examples, for example, for like investment for like VC studio, right, to evaluate the business idea and also do a lot of analysis about market analysis, competitive analysis, and generate investment memos and so on. So that's another good example from this studio called Better Future Labs. They have started doing this deep research kind of
Yeah. So I was gonna say
even 1 year
now.
ago.
I I was going to say now you can do all of this deep search, deep research.
Yeah.
There's several tools now, right?
Yeah, exactly.
Yeah.
And what's remarkable is they started very early, like at least 1 year ago. They have been doing that and generate very high quality result using AG2. Yeah.
And also,
Yeah.
if you have a lot of internal data sets that are valuable, you may not actually want to use one of these deep research tools anyway, right? So, or they won't be able to see your data anyway, because a lot of them use the public internet data on the internet, right?
Yeah.
So you may still need an agent to go through your internal systems, right? So,
Yeah, that's right. Yeah, there's one example recently we learned from Cambridge, who studied how to use AG2 to build self-driving cosmology laboratory. So they have huge amounts of cosmology data that are collected from the telescopes all over the world. Its volume is higher than most of the big internet traffics, actually, Facebook, YouTube, and so on. And how to analyze that data efficiently. So they built some agents that leverage the both like language capability and also existing software that's already built for some of the tasks, but the agent now can automatically do that and reduce the human analyst time for like 1 day of work to just tens of seconds.
so do you have an example of something the community built that's clearly multi agent?
All of the examples I
All of
mentioned
these are
are
multi
actually,
agents. Interesting.
yeah. Yeah,
Interesting.
and there's one more I want to mention, that is the software engineering domain. You know there are some very hard benchmarks like Sui Bench
Mhm,
contains real GitHub
mhm,
bug fixing
mhm,
tasks, and in last kind of November or December, there was a top ranked solution from a very small team, actually from Colombia, I think, but they reached the top performance on the Sui Bench Lite benchmark. And the solution is using multi-agents, but quite efficient. They can fix nearly half of the bugs, and using just within $1 per each, and just spends few minutes to fix each bug. So that's quite remarkable. So I've seen a lot of that example, like from uh, this community, from small teams, and they traditionally it's very hard for them to uh, tackle these hard, challenging benchmarks and problems. Now they can. Yeah.
So I would imagine that as the foundation models get better, the capabilities of the agents get better, right? So
Yeah.
now the most recent developments are around these reasoning enhanced models.
Mhm.
And we're increasingly seeing these visual language models. I mean, the
Yeah.
new latest version of the Google Gemini models, the
Mhm.
3.2 or whatever, that are doing reasoning, they're also multimodal. You can feed them audio, video, and they can really understand what's going on in there. So, uh,
Yeah.
what else would you like to see from the foundation models in that would really help the agent space? Is it so? One thing that a lot of people talk about a lot in this agent space, Chi, is GUI interactions, right? So the fact that a
Yeah.
lot of knowledge workers actually still, a lot of their tasks still involve working with graphical user interfaces, right? So
Yeah.
I would imagine any improvement of the foundation models in that direction will obviously translate to better agents, right? So what else would you like to see from foundation models?
Yeah, what you said is definitely one of them. That's very interesting. Computer use and interacting
Yeah.
with web browsers or the operating systems. What else? I think as we kind of improve these uh, fundamental agentic capabilities more. So let's say suppose we have reasoning, we have this interaction like computer use and operating system capability of the agents, and we have multimodalities. After we have the relatively kind of specific uh, basic capabilities built into the foundation models, one other capability I want to see at a higher level is the capability to do kind of planning, higher level planning or orchestration, or even like knowing how to organize the like more specific agents. So that's kind of at a different meta level, but similar to the captain agent idea I mentioned earlier. So that because once we have that, then it further reduces the effort of manually thinking about how to combine these different specific agents together. Because now, as you see, we have the reasoning model, we have non-reasoning model, but they can't replace each other, right? So reasoning model can do certain things better than non-reasoning model, but vice versa. It's not like strictly better for one model to be another. And similarly with the other things. So once we have more and more specialized models, we still need to choose them for the right task. But from user point of view, if we can have one a single agent that helps doing all of these, it'd be nice. Do we need to improve the foundation model to achieve that? It's an open question. I don't know, but if so, if we do need that, then I'd like to see foundation model to improve on that front.
So you mentioned planning, right? So a lot of people
Mhm.
now who
Yeah.
listening to this podcast are interacting with reasoning enhanced models. So they have a concrete
Mhm.
understanding of what is meant by reasoning, right? So can you make
Mhm.
planning more understandable for our listeners? What do you mean by planning in this context?
Yes. In this context, what I mean is when user provides a task, the task may be very ambitious. It may contains a lot of steps. For example, if the user say, "I want to generate a Hollywood movie. I want to generate a Disney movie," and
Or what about the
yeah,
canonical example from many
yeah,
years ago, Chi, which is basically I want to book a
yeah,
complicated international flight which stops in 5 cities, stays in several hotels, right? So that kind of
yeah,
thing, right? So, yeah,
yeah. Exactly. Travel planning is a
yeah.
very good example. Yeah. So then, to solve that problem, agent need if the agent can solve that all by one shot, then we don't need the planning. But if we do need to involve multiple steps and even sometimes dynamic workflows that need to be changed depending on the initial steps, then we do need a planner to first come up with the initial plan, break down into sub steps, and then assign them to maybe more specific agents to solve each of them. And at a certain time point, after the sum of the steps are finished, the planner needs to revise the plan and suggest new steps or remove steps and so on. So that's sort of the responsibility for the planner in this process.
You know, Chi, in many domains, right? So one of the things that humans bring to the table, there are many things that humans bring to the table, right? So there's creativity,
Mm,
there's critical
mm,
thinking, right? So I mean, and just basically one manifestation of critical thinking is your ability to ask the right question, right? So for example, imagine you're a financial analyst. What's the value of Tesla, right? So then you can look at all the public information, but the best analysts probably kind of understand what's the right question to ask in
mhm.
order to
Yeah,
get to the root of this, to get to the right answer, right? So
yeah.
is that more on the foundation? That's a problem with the foundation models that so you folks building tools for agents, you're waiting for the foundation models to get better at a lot of these aspects, or is that something that you on the agent OS side can start addressing?
Yeah, that's a very interesting question. I think this is something I want to mention. That is, the agent OS can actually help with improving the foundation model and play a big role of it. The reason I say that is, um, if we take any models today, right, we always can find some some limitation of them. For example, before we have the strong reasoning model, they used to be weak in reasoning. So at that time, how do we improve the model's reasoning capability? So one way you can do that is we first take the weak model. They're not good at reasoning, but we can use the agentic approach, build multiple agents, each of them focusing on specific tasks, but combining them together, we can perform this multi-step reasoning, back and forth search, navigate the design space until we find a good path. Actually, we already did that. So recently, we had this new reasoning agent feature in AG2, which did exactly what I said. It allows users to use any models, not just the thinking models, to have the similar behavior of the long-term reasoning. And also you can control the thinking process and can see all the thinking process. This is much more flexible than simply using the thinking model. But the benefit is that after you do this agentic reasoning, you can take the data generated by these agents, right? You can take both good examples and bad examples, and you can do whatever you want, like data selection, and then take that data to train to further improve your foundation model. And actually, that's a very effective way to go from weak model to stronger model. And after reasoning, we can do other things. So anytime if you take the state of the art model and you add add agentic approach, you can typically reach a new level of capability, and the data generated by doing this can then be feedback into foundation models. I think that there's a very good loop there.
So we talked about reasoning and planning. So what's your answer, Chi, for creativity and curiosity? You know,
Yeah,
so humans exhibit both of those, right? So
yeah. This is quite interesting because the example I mentioned earlier about by the Better Future Labs, what they did essentially, the team of agents that simulate our organization of hierarchical structure that have different roles of agents, simulate different behaviors of the humans. For example, they have a director that give high-level
interesting.
instructions to several managers, and each manager manages multiple researchers in the team, and the manager will actually take director's instruction and think about questions, write questions creatively, and assign them to the researchers. And not only that, after the researcher comes up with initial kind of result, the manager actually will try to criticize them, figure out what is not desirable, and push the researcher to further improve and go beyond their limits.
Interesting.
So that's quite like what you said, and that's the reason actually they were able to generate very high quality report in the end.
And by the way, what you just described there, I can even have several managers, right? So manager number one is backed by
Yeah,
Gemini. Manager number two is backed by DeepSeek, right? So
yeah,
manager number three
totally,
relies on OpenAI, right?
totally. Yeah,
Yeah.
that's I think that as the models getting more and more diverse, and each of them have different strengths and weakness, I think the combination will have a bigger effect compared to using a single one.
And what about I guess evaluation challenges around this type of agentic, especially multi-agents, right? So it's hard enough to
Yeah,
evaluate single agents, but how do you evaluate whether or not the multi-agent, I guess it produces an output, and if the output is acceptable, or if there's a natural way to validate the output, like if it's a coding task, right? So you have a way
yeah,
to naturally validate, but some things are subjective, right? So
that's right. Yeah. So this is actually this is another example where agents can help. Um, for human to manually kind of look into the logs is very time consuming, and it's very inefficient. But the good news is the language models are actually very strong at understanding uh, the process and quickly kind of summarize the problems. We did some, okay, I'll give two examples of work we did. The first one is called agent eval. It's like one agent looking at the process and come up with dimensions to evaluate the task. Let's say the task is math problem solving. Not only we can evaluate the success rate, we can also get deeper insights by breaking down that overall successiveness effectiveness into several criteria, such as how good is the problem understood, how good is the method selection, and how good is the calculation, is our calculation error, and so on. So we can evaluate the different aspects, and the agent is able to automatically suggest that actually for human. We only need to provide a task, and agent will break down and then score the performance against each dimension. That provides more detailed insights. So this is one example of just evaluating a system overall. But recently we also did another work to analyze this multi-agent system behavior and try to identify who is the major blocker, like which agent is not good enough and should be responsible for the major issue in the system, so that we can focus on maybe improving that agent first. And we also can identify where it goes wrong for the first time, instead of we manually look at the entire process, and it's very slow to find that. So in general, I think multi-agent system actually provide a better way to evaluate and test system, because we can do more specific unit testing on some specific agent on specific tasks. That's actually feedback from the community users who have found that's a more effective approach that have a more single monolithic architecture.
So multi-agents, right? So let's take the example of the chip design, right? So I was able to produce a decent chip design using this multi-agents. Now, if I went to an engineering team and had the people do that chip design, I can ask them, hey, can you guys explain to me how you did this? Right. So, what's the rationale for all for the design that you came up with? Right. So in the case of multi-agents, what's the explainability? So,
Yeah.
because explainability is important for user experience, right? So people are more comfortable if they understand how did you arrive at this decision, right? So,
yeah, exactly.
yeah.
So this is I think requires two things at least. Maybe there are more. So one is the reasoning capability. So when we talk about reasoning, it often means that the agent not only needs to provide the answer, but also need to tell you all the reasoning steps. How did they come from the beginning to the second step to the third step? So once you understand each of step and you are convinced about the reasoning of each step, you are more convinced about that the final answer is
Which
correct.
now we're starting to get with these reasoning models, right? I mean, the DeepSeek model even spits out the reasoning tokens, right? So,
yeah, that's right. That's one, and I think that's the one fundamental capability we need to have from the model. But the second part, that is like so for the chip design example, the human, because human usually have some unique kind of expertise that models doesn't have. So if the model give you some plausible reasoning, but that actually doesn't make sense, the human will not be convinced either. The human will quickly realize
you
they
can
have knowledge.
imagine the different agents in this process, produce the reasoning steps, because whatever, they use reasoning enhanced models, right? And then you combine all of those reasoning steps, and then you ask an LLM, provide a narrative so that I can explain the decision making process. And then you inspect the narrative, it doesn't make sense. And then you maybe not trust the answer, right?
Right. And another important part is the knowledge used may not necessarily be in the model already. And so not only we want to have the textual reasoning from the model itself, but we also want the model to be able to tell us when it uses external tools, for example, from an existing database or knowledge base, and instead of you rely,
or a chip design software, right? So
through the software and or some human written kind of instructions that is not in the model itself. So if model can also properly show us that at the right time it doesn't rely on itself internal knowledge, but use external knowledge in the right way, that is also helps with convincing human experts that okay, this model knows when to use tools, knows when to ask for help, and then can solve the problem, not because the model already knew by themselves, but because they can leverage the external information properly.
so what's on the near-term roadmap for AG2? Near term, I mean 6 to 12 months. So what are some of the top 2 to 4 priorities?
Yeah, so broadly, I think there are two categories, or maybe three, and because the strongest capability of AG2, as you see, is this flexibility of enable advanced users to quickly try out different ideas, and that for that is still still area that we need to keep going, because we want to provide more and more such convenient capabilities. For example, the cabinet agent direction. We're just started, but we want to make it really strong so that this manual effort of users developing the management system can be further reduced. So that's a big area of improvement. And there are two other kind of parts that is also as important for getting wide adoption. The one is to make it very easy to get started, because right now there are a lot of features in AG2, and how do we enable users to quickly find what they want? And the third part is after they find it working, after the prototyping phase, they want to deploy in production, so they need the right tools to quickly, easily enable them to connect with different UIs, with different environments or infrastructure, right? And build all the tools for them. So there are three kind of high level buckets, but the first one is still, I think, the major strengths, and we will still need to do a lot of work to make sure it's ahead. It can support most advanced AI technologies, multimodality, for example, and also advanced applications people want to build. So that's still one areas that we need to be the lead. And for the other areas, I think we just need to be good enough for people to use them. Yeah.
And I guess let's close by reassuring our listeners, because we've been talking in a way that seems to make it appear that knowledge work will completely disappear. Because Chi was talking about an example of a scenario where you have agents acting as managers and directors and managers of managers and scientists and engineers and programmers. So listeners may be wondering what will be left for all of us to do. So Chi, I'll give you the floor and reassure our listeners about the future, where we do have a truly tools like AG2 that really make it easy to build multi-agent applications.
Mhm. Yeah, I think short term, it still will not happen because there's still a lot of problem issues. Even the idea is nice, but they're often for short for complex tasks, and
Yeah.
we have plenty of such examples. So
Yeah.
actually, these are the areas I want to improve also. And long term, I do believe that in future if we want to delegate certain tasks to the agents, we can. I think we will reach a point that many of the tasks we can delegate them. But at that time, we still need to think about the important question: when do we want to delegate, and when do we want to do it ourselves? I think it can be maybe the one big question that for most people in the future. Once we are able to do the delegation with, do we still have like free will? How much do we kind of drive the things ourselves, and how much do we run agents? I think that's going to be an increasingly important question, maybe in 10 years or so. But for now, I think there's still many hard problems to solve to really make them working on behalf of ourselves, faithfully follow our guidance and instructions.
And in closing, again, the website is ag2.ai. It's completely open source. There is a startup, although Chi himself is working only on the open source project. And Chi, I guess I forgot to ask you up top. So AG2, is it, are people mainly thinking of AG2.ai for, I guess, cloud and server applications, or are people also looking at it for mobile and embedded devices?
All of that. So
All
I've
of that.
seen examples in all of these different types of
Yeah.
applications.
And with that, thank you, Chi.
Thank you very much, man.